we are going straight to the other theorems that we didn't look at yesterday. Just a recap of what we did. We said if we draw a circle and this is a chord, and this chord is subtending an angle at the circumference, maybe like this. This is the angle subtended, and then it subtends another one, maybe like this.
Yes.
These two angles, if this is 30 degrees, then this is also 30 degrees. Angle subtended by the same chord in the same segment, they're equal. We can say same chord or same arc. Then we also had a theorem that when a chord is drawn here and the center is there, one angle is subtended at the center, another is subtended at the circumference. We said the one at the circumference is half the one at the center.
Okay.
Then we also said if we have got a circle and we have got a center and there is a diameter, angle subtended by the diameter at the center, at the circumference, sorry, is a right angle, that is, it is 90 degrees.
Yes.
We also said that if a circle is drawn and we have a chord and another, so that at the end of the day, we have a quadrilateral inside the circle with all four corners touching the circumference. We said we call that a cyclic quadrilateral, and we said opposite interior angles are supplementary. That is, they add up to 180, like this one and this one. If this is 1 degree, this would be 179, so that they add up to 180. But we also spoke of exterior angles that we get by extending this. If we extend them, we've got angles like this one. It's an exterior angle. So we have another law that says opposite interior, like this is the interior, is equal to opposite exterior. So you go opposite and the exterior. We are no longer talking of supplementary, that is adding up to 180. No, this time we're saying they are equal. If this is 1 degree, this is also 1 degree. I think these are the 5, because here there are 2. Are they not all the ones that I taught you yesterday?
Yes.
All right. So now we want to move to other theorems, most of which will be having what we call a tangent. So let's look at that. Let's look at that. So if I draw a circle like this, and then I draw a tangent, which is a straight line that touches the circle and pass. It doesn't cut inside. It just touch like this and pass. There is that point of contact that we get to have. If it is established that this is the center, a line can be drawn from this center to the point of contact of the tangent in the circle. When that happens, the line that is coming from the center and this tangent, they meet at a right angle, meaning they form 90 degrees, this side as well as the other side. That's just the theorem.
Yes.
This can be a radius like it is right now, or it can be a diameter as it stretches. For as long as it passes through the center, coming to meet the tangent at the point of contact, then yes, it's going to be a 90 degrees. Any question?
No, sir.
Good. So if we draw another circle, and this time we say there is a point outside, an external point, but from there emanates a tangent like this, touches and pass. And from there emanates another tangent which shall touch and pass. Yeah, then the distance from the point of contact to that external point Same here, the point of contact. These are equal. So this now is equal to this. We just need to know that these will be equal. This can go as long as it wants. We no longer care. We just care about the point of contact to that external point. The theorem says tangents emanating from one external point are equal, at least from that external point to the point of contact. If one then, say, joins these points of contact like this, then we form a triangle that is called what?
If it joins.
Yeah, like I did. I formed a triangle here. What is the name of this triangle?
Isosceles?
Isosceles, yes. But they are not going to show these that can remind you that they are equal. So you just need to know that when you see one external point and you see tangents emanating, they have to be tangents. If a line cuts inside through this, no, then it's not a tangent. It's a tangent only when it touches and passes, doesn't get inside the circle. Careful of diagrams that may want to confuse you there. But I also want to talk about, let's say we have our center here. And then at the end of the day, we have got a line from here to there. What is the name of this line?
Radius?
Correct? What about this one?
Still a radius?
Correct. So we now have a four-sided shape. What is the name of this shape?
This is
this side is equal to this side, while obviously this one is equal to this because they are all rather.
It's a rectangle?
Rectangle, no. Hey, rectangle. Rectangle is the one you know from primary, remember? Rectangle, it never changed to become this. What kind of a rectangle that would be? A rectangle, we have got 90 degrees here, 90 degrees there, 90 degrees there, 90 degrees there, and opposite sides are the ones that are equal. This side is equal to that, while this side is equal to this side. That's a rectangle. And this isn't like that. Children likes to play with these things when it's windy.
Kite.
Yeah, it is a kite. It is a kite. This is a quadrilateral with a special name kite. I also wanted to say that always this angle and this angle are going to add up to 180.
Okay.
Because this is already a 90 there, and this is already a 90 there. So 90 plus 90 is 180. Since if we add all the interior angles of a four-sided shape, whether square, rectangle, rhombus, parallelogram, trapezium, and this kite, when we add all the interior angles of a cycle, of a quadrilateral, they must add up to 360. If 180 is already going there, between these two, we must have 180. So knowing this one can help you know that one, and knowing this one can help you they add up to 180. But I also wanted to say what? Another property of a kite is that it have got one line of symmetry here.
Okay.
Meaning it can divide a kite into two equal right angle triangles, please. Okay, that's enough about that theorem, which states already, like I've told you, I just wanted you to know that those two sides are equal, meaning that these base angles are going to be equal as a property of an isosceles, which you already told me that this is an isosceles. Also, there is another isosceles here where this angle will be equal to this one. All those things help you to get all the angles you may want to find in that particular question you might be dealing with. But I have another theorem that involves a tangent. If a circle is drawn, and then let's say let's say we have got a tangent here. Let's say we have a tangent here. Then this point of contact, from this point of contact, we can have a chord in this, for this circle like this. That's a chord. Okay, it's a chord if it gets to the circumference again. Right. Now that's a chord. We focus on this chord. There is an angle this chord is making with a tangent. I want you to see it. The angle is this one. This is an angle formed by a tangent and that chord. This angle is equal to any angle this chord is going to subtend in the other segment. You know, a chord divides a circle into two segments, this bigger segment and this smaller segment. So there is this angle. It's not fully contained in this segment, but yeah, we can see that it is on the side of that segment. If this chord subtends an angle, let me show you an angle that it can subtend. Let's say it's like this. So here is an angle subtended by this chord. This angle and this chord are equal. If this is 51 degrees, this is also 51 degrees. This demands some abstract. Most students do not quickly understand this theorem, but explaining it again, we are saying that if we see a tangent and then we see a chord like this lime green chord, there is an angle that this chord is making with the tangent.
Yes.
That angle is equal to any angle that this same chord is going to subtend at the circumference in the other segment like this. So if we follow that well, we can see that even this one is a chord. It's also forming an angle with tangent this side. True?
Yes.
Yeah. The theorem still works and says this chord that participated in making an angle with a tangent, this angle will be equal to the angle this chord is going to subtend. And yes, there it is, an angle subtended by this chord we are talking about right now, which made this angle with the tangent. It's going to be equal with that one. Okay?
Yes, sir.
Yeah. So, yeah, maybe the last theorem I can give you is the one that says if we establish that this chord is equal to this chord, this is 5 centimeters, this is also 5 centimeters, or whatever. We are saying if this chord goes on to subtend an angle, like this angle, then this one also subtend its own angle. These angles are equal because they are subtended by chords that are equal. So equal chords subtends equal angles at the circumference, and vice versa is true. If I don't tell you that these chords are equal, but I tell you this is 30 degrees, and then I say this is 30 degrees as well, it follows that whatever the dimension of this chord is the same that side. Okay?
Yes.
So we are done with the theorems. Let's look at the equations and try and answer them. We'll just look at the diagrams and put as many angles as we can find before we even probably look at the question, what it is actually asking. Are we going to get a circle geometry question here? Are we? No. Let's try this one. Oh, there it is. Number 14 there. So we have a diagram here. We have a diagram here. They are saying A, B, C, D, and E lie on a circle. A, B, C, D, E. Just assurance that those corners are right on the circumference. So there's no doubt that they are on the circumference because our theorems depends on it, most of them. Then FG is a tangent. We have assurances. FG is a tangent with a point of contact at C. So it's a tangent to the circle at C. Right. Angle BAD is 110. It's well labeled. Angle ADB is 20. It's also well labeled. Angle BEC is 45. It's called BEC because from B you go to E, then you tend to see there's an angle formed there of 45. All that is labeled. We don't worry about the questions, like I said. Let's just try and figure out how many of these angles can we actually find. So look at me doing this. I could this code here. So we need eyes here. That sees amongst these many lines. I want you to focus on this chord BC. Is it subtending any angle you can see at the circumference?
Yes. It's E.
At what?
Was it E?
At what?
E?
Yes. Yes. And it's actually 45 degrees there. That's actually correct. But because we have a law that says angles subtended by the same chord at the circumference in the same segment, they are equal, could you find another angle subtended by that same chord? So we know it also 45. Can you find it? So this chord ends here. The ends of this chord here. So you said E, and I said it's correct because there is a line from this end meeting at E there, and another from the other end. Is there any other angle with lines coming from the ends of this chord meeting somewhere at the circumference? Because that's what would be being subtended by the chord BC. Follow the lines. Any line from here and from here meeting somewhere at the circumference besides the one that you have already told us, 45 here?
D?
Yeah, correct. Because there's a line here, clearly, that is coming from the end of this chord. There is the line. There is the line. And another from the other end, there. And the two are meeting to form an angle. Therefore, that angle is subtended by that chord BC again. Therefore, this is 45. So we applied the law theorem to find that that angle is 45. All right. The last theorem we did, it said if you see a tangent, it's a theorem that you can think of when you see a tangent, and you are seeing one. And so this same chord we just worked with is formed an angle with a tangent right here. Didn't it? It did, right?
Yes.
And we said that angle would be equal to any angle subtended by that chord which made an angle with a tangent. And we already know that this chord is subtending an angle of 45. Therefore, this is also 45. You get that?
Yes, sir.
Good. So we now know that part is 45. We also know that if you add all the interior angles of a triangle, they must add up to what?
180.
Correct? That's correct. So if you isolate triangle ABD, let me show you triangle ABD. From A, go to B. So that's A, B, then go to D. Then go to D. There we are going to D. So you see the triangle we're talking about.
Yes.
Why did I choose that one? I'm clever enough to see that this angle is given and this angle is given. Only one angle is not given. This one. I'm ignoring a line BE. For that triangle, line BE to me doesn't exist at the moment. I'm focused on this triangle, and that angle there, we have to find it. If we know that if we add all the angles of a triangle, we must get 180, and two are already known with 20 and 110. What is the size of this angle here?
50.
How did you find it?
120, 110 plus 20, which is 130, and then 180 minus 130.
Which is good. And you get 50. So this whole angle, remember I'm ignoring this line. This whole angle ABD is 50. Yeah, so we have found it there. Right, we are trying to think, those theorems we have, and which other angle can we find? Do we still have angles we can find? There was that theorem that says angle subtended by the diameter is 90 degrees. That one is out because we don't have a center. We're not given a center, so we don't have a diameter. Even if this line may look like it is a diameter, it is not. What makes it a diameter? That's why it is subtending a 110, not a 90 as the diameter is supposed to. So that is out. All the theorems that worked with a center are out. A line from center meeting the tangent at the point of contact forming 90, that's not there. Because this is not a diameter. It's not passing through the center. If there was a center, we would be told. Right. Also, the one that says angle at the center is twice the one at the circumference, or the one at the circumference is half the one at the center. It's not going to apply. So which one can apply here? Quadrilateral. Yeah, we can form a quadrilateral here, can't we?
Oh, we can.
Yeah, we can. So we can ignore all the other noise of many lines and just focus on a four-sided shape whose four corners are touching the circumference. I can think of this one. Can we focus on that?
Yes.
Yeah. Right. We are saying opposite interior angles are what? Of a cyclic quadrilateral, they are what?
Equal to opposite exterior angle.
I said opposite interior, so I'm not working with that one of exterior. I'm working with the first one where we said opposite interior angles of a cyclic quadrilateral are what?
Are equal.
There is that one which says opposite interior is equal to opposite exterior. Yeah, I'm not talking about that one. I'm not talking about that one. I'm talking about the one that says opposite interior, or interior versus interior.
The
What do we say
supplementary.
about it? Yes, they are supplementary. They add up to 180. Yes. So we can, because we know the opposite angle here, the 110, huh? If we go opposite is this side.
Yes.
So can you tell us now what this angle is going to be?
It would be 70.
70. So that when we add 110 plus 70, we get 180. That is being supplementary. So you're quite right there. So that would be 70. The whole of it there would be 70 degrees. Good. So we found another angle there. Interesting. Remember, on a straight line, we also said that from here to there, how many degrees?
180.
Correct. angles in a straight line are equal to 180. So we have got, which color can I pick now? Okay, let me pick this one. We have got a 45 here and a 70 here and one that we don't know. But then we know that this plus the one we don't know, which is this one, must give us 180.
Yes.
So what is that part we don't know?
It's 65.
How did you get it?
Added 70 and 45, then subtracted it from 180.
What is 70 plus 45?
115.
115.
Yes.
What is 180 minus 115?
65.
So you are right. The answer is 65. Careful. I didn't think I marked that angle well. 70 ends where? 70 ends in that line. So my markings should start from this line to this line only. Okay, so 65 is that part. What is interesting about this 65 is that it is an angle formed by a chord and a tangent. And there is a theorem, remember, that says if a chord like this chord CD forms an angle with a tangent, that angle is equal to any angle that chord is going to subtend in the other segment. And it happens that this chord CD is actually subtending an angle here. Can you see that? Because it's an angle formed by a line coming from C and a line coming from D. So chord CD is subtending an angle there. And since the theorem says they are equal, so this is also 65. Okay?
Yes.
Good. I could have gotten this 65 using another theorem. Like, I know what this whole angle is. In a cyclic quadrilateral, remember our cyclic quadrilateral that is brownish?
Yes.
If this opposite side is 20 plus 45, it means it is what? The whole of it?
65.
65. So since this whole other angle is the opposite, what is this whole angle supposed to be?
115.
Since opposite interior are supposed to add up to 180, that one, yes, you said 115, that's already correct. But on that 115 that belongs to this whole angle, we can remove the 50, which we know is this part.
Yes.
So 115 minus 50 is what?
65.
So I could have arrived at 65 by using another theorem, longer though, than the one we used, just for you to see that you can play around those things that way. Your theorems, if you know them, you can apply them and get as many angles as can be found. Do you see any angle that we can find to be there? We haven't just looked at the question, we're just practicing how to apply our theorems. So is there any other
No.
angle that you think you can find here? This one, I could have found it if I knew this angle. But 70 is not for this angle alone. 70 is from here to there. But maybe I could find it, could I? Maybe. We would just say 65 plus that angle if we get to find it. Then from 180, focusing on a triangle here. Then we have an issue of that x. You remember that x where we said this angle would then be equal to this one, while this one would then be equal to this one. The z angle and f angle will not apply here because we didn't hear anywhere where we were told that lines are parallel. There can be questions with parallel lines. We can apply that, but not in this question. Let's just check to see which were the questions. Find angle BCD. That's the first question. B,
C,
C, D,
70.
which is 70. Do you remember how we found it? Because the question says give a geometrical reason for your answer. So you'd say the answer is 70 because. Do you remember how we found 70 on this angle BCD?
We we said angles in a cyclic quadrilateral are supplementary. So then we removed we said 180 minus 110 to get a 70.
Yes. So that's the geometrical reason which you mentioned, that opposite interior angles of a cyclic quadrilateral are supplementary or they add up to 180. That's your reason. So you write that here.
Okay.
Find angle DBC. Is it an angle we've already found? DBC, 65. Yes, we did find it. What is your geometrical reason? They didn't ask for it anyways. But yeah, how did we find this 65?
Okay, let's say that opposite interior angle is equals to opposite interior angle
Of a
is
cyclic quadrilateral, please don't leave
okay,
that out.
yes, of a cyclic quadrilateral is equal to the opposite exterior angle. Or we could have said since opposite interior angles in a cyclic quadrilateral are supplementary, we could have said 62. Yeah, if this is 65 and we add the 50 that we found here, and then we remove it, which is 115, and then we subtract 180 minus 115 to get the 65.
Yeah. You chose the longer one. Like I had said, many students are not comfortable with this other shorter one, where I said if a chord and the tangent makes an angle, that angle is equal to the angle that chord is going to subtend in the other segment. Is how we first found 65. But what you said is also correct, and the reason was not asked this time. It was just 65 degrees, and then you get your 2 marks. They also want you to find angle DCG. DCG. From D, go to C, then to G. Oh, we had already found that. And probably, if you had found it that way, you would then say angle subtended by a chord is equal to an angle the chord will make with the tangent at the point of contact there. So the reason was also not being asked for. Right. I have another one. Do we have a center on this one?
Yes.
Definitely. And then that helps us to, out of all the other theorems that we know, we can just focus on the one that deals with the center. That should give us something. Which theorem do you think we can apply to get which angle?
I think there's a right angle.
Yes. The right angle is at which corner?
B.
Yes. the angle at the circumference there is right angle because it is subtended by a diameter, and this is a diameter because I can see that it's passing through center, or that I'm told here, confirmed here. So that would be 90. It will be easy to get this angle, isn't it? If you know this is 90, but you already know this is 39. Can you fail to find this one?
That would be 51.
That will be 51. How did you find it?
I did 39 and 90 from 180.
Yes, you add these two, and then you say, oh, by the way, if I add all three, they must give me 180. So 180 minus total of those two, you get your 51. And that was the question. Work out angle BCA. BCA, 51. Huh? You can enjoy these things when they are done right. There is nothing really difficult. Okay, that's not circle geometry. We shall come back to polygons. It's still easy in circle geometry. All right, that X thing, you remember it? And the parallel lines, the F angle and stuff. Although
Yes.
this is not really circle geometry, you can skip it for now. We don't have circle geometry here. Let's just answer this one for interest's sake. Let's just answer this one. It's an interesting one. Before we move to the next question paper. So I want you to know that these are parallel lines. So the Z angle on the F angle that we learned yesterday, they're in the other video. Okay, we can say the angle on top of the parallel line is equal to another angle on top of the other parallel line here, meaning that C is equal to E. But the one below as well is equal to the one below the parallel line. That's the F angle we are dealing, meaning D is E. I didn't look at the question, whatever it is asking. I'm just saying. And then with the X thing, remember this D, this C will be equal to this A. And this E would be equal to this G. Since C and E are equal, it follows that C, A, E, G are all equal. So we can add the A, we can add the G there. They are all equal. Same applies to F, H, D, and B. So the F, H there we add, and D there we add. All these four are equal. We could also, yeah, we could have used the Z angle as well. Look at the Z there. Go there, go there, go there. That would tell us that this A is equal to this E. So it's messy now. But the A and the E, we already know they are equal because we already said it here. A equal to C equal to E equal to G. All these are equal. What was the question anyway? Complete these statements. Angle A and angle dash are corresponding angles, right? So it's angle A and angle what?
And angle E.
Angle A and angle E are here. They are what?
They're corresponding.
As well, right? And equal angles. They are equal angles. A and E are equal angles. So, right. And we didn't have equation in circle geometry here. Also don't want to finish them all. So I want you to try on your own, but you're doing well right now. You are a first learner, or I am a good teacher. I don't know which is which there. All right, so we have this situation here. There is a center, so those theorems with center can come in. Then we have got tangent. So those with tangents can also come in. Oh, this one. Okay. So OP is a what?
OP is a radius.
Okay. What about OS?
Radius.
So this and this are equal. They won't tell you, right?
Yes.
Battery is complaining. Don't know why when I was supposed to have it plugged in. Just give me a minute. Okay, so it's actually not changing this thing. All right, just don't know where the connection is. All right. So I also wanted to so what does that mean about triangle OPS?
It's an isosceles triangle.
Yes. So how does that help you to find X?
If it's an isosceles, then x is 25.
Exactly, because they're supposed to be equal, these angles. If this side and that, this side and this side are equal. So X equals to 25, easy.
Yes.
Right. We are supposed to find Y as well. I'm sure they'll ask for Y, but without rushing to Y would be easy to find if we get this, because we would know that this plus Y must make a 180. So can we find that one, that part? Maybe we can, but for us to find it, we need to consider. For us to find it, we need to consider this as a triangle. You see this one,
Yes.
and then we go this way, and then we go this way.
Yes.
That will form a triangle, which can help us to find that. So what do you think we should do? What if you put it on the elevator?
Should.
Yes, searching. Okay, so we are saying, yeah, you were about to tell me. You're about to tell me.
We should. Oh. Is S a tangent? So that would make it 90 degrees.
There's no tangent. Oh, there is a tangent, yes. Yeah, exactly. This is 90 degrees. Exactly. Very good. That's what I wanted you to see, that there's a line from the center meeting a tangent at the point of contact. They should form a 90, but we already know this is 25. So 90 plus 25, that's the whole angle of this part. And what is 90 plus 125? Is it 115?
Yes, 115.
So since this is 25, this is 115. So what is this one?
That would be 40.
That's correct, because you said 115 plus 25, you got 140. Then
Right.
you said a whole triangle, when you add all, should give 180. So 140 from 180 gives you 40. And that means our Y is what?
140.
It's 140. I want to believe those are the two questions asked. And the reasons, you just mentioned the reason. Reason was this where in an isosceles, those two were equal. Base angles, whatever you call them, are equal in an isosceles because that's a radius and a radius, so it forms an isosceles. That's how you found it. You explained that here. Then find the value of y, which you did. Right. The one that is coming should be, I hope I get it so that you can have some homework. This looks similar to the one we saw before. But no, it's not. It's looking like we are not going to find an question on circle geometry. You have to find it. Your prayers are strong against homework. Let's see the last one. Yeah, we got it. This is your question. My advice is don't focus on finding x and y first. Focus on the angles you can find.
Okay.
Find all that you can find first, and then you can come back and look at the questions being asked. So I'm making a screenshot, then share it with you through WhatsApp.
Okay, sir.
Right, screenshot is mad. I want you to confirm that you have received. I just sent it.
Yes.
Good. Any questions from you?
No, sir.
Okay. Try that question. Can you find two more, please? Find other question papers. Find two more questions that we didn't do on top of this one as your homework. We meet on Friday.
Okay, thank you, sir.
Bye-bye.